Hello, welcome to another episode of Xa Talk Show. Today we are going to code Emacs Lisp. There are several things to do. So coding Emacs Lisp, okay? So I'm wondering, there are several projects that we may do. So let me show you what they are, okay? So go to Emacs, actually go to Xa Talk Show topic notes. So one of the problem I want to do is write a Emacs Lisp command, write a Emacs command in Emacs Lisp that does common and uncommon code. For example, I'm in HTML, I can press a key, then we have comment in HTML. It may be in Python, in JavaScript, in whatever language. So one of the things to do is to write this from scratch. Let me mention, if you go to Xali Emacs Lisp tutorial, just search for it, practical Emacs Lisp, you'll find my website. So we did practical Emacs Lisp, then you click on write a major mod. So we did 4 videos actually, on writing a major mod. Each one is independent. So, and we did 2 or 3 of them this year, recently, last month. So check it out. And when you want to write a command to comment, you can use the built-in library. So there's a built-in library. You click on write a major mod, then you click on standalone command command. Okay, so there are 2 ways to do it. One is the command command, which relies on the built-in library newcommand.el. That's in every Emacs. Okay, so if you use the built-in library, all you have to do is just add 2 lines. Your programming language is common start characters and common end characters. That's so simple. All you have to do is just add 2 lines and, of course, load the library. But I'm thinking, but in some cases, you want to write your own command command. For example, in the Wolfram language, let me show you Wolfram Mathematica. So Wolfram, so for example, let me start Wolfram mod. Okay, so right now I'm in Wolfram mod. If I want a comment, that's a comment. You can see, let's magnify. So this is a comment in Wolfram language. I believe this is also used in Pascal and AppleScript. I forgot. But anyway, there's I have a lot of, it's used in a few other languages. Also use this, maybe OCaml, I forgot. So this is Wolfram language comment. So when your comment syntax of your programming language is unusual or not the typical C or C++, slash or slash asterisk, that's C and C++ and Java. Or for example, in Python, that's a pound sign, Python, bash, PowerShell. That's the most simple. If your comment is a bit more complex than the typical ones, then you might have a problem using the built-in library, the newcommand.el. But actually, I haven't looked into. I should look into. So that's one of the things we should do. So do we have people watching now? 3 people. Fantastic. Grand total of 3. So since we've been talking about this already for 5 minutes, let's just do this. Okay, there's other project, but let's just focus on doing this today. So we are going to write a common and uncommon command in Emacs Lisp for the Wolfram language. So let me detail what does it involve, what does your code needs to do. Okay, for example, common, uncommon. Okay, you can also select part of the text and call comment. You just comment that part out. Fantastic. right now it's using the built-in. Right now you see it works, but I'm using some Wolfram mod, and it's right now I'm implementing it using the built-in library newcommon.el, but it's got some problems. Let me show you what is the problem. Okay, so for example, I comment out the whole line. Let's say some more lines here. Okay, comment. Okay, wait, cut it. So I want to make it, Wolfram language comment is multi-line comment, so you can comment that way. But then suppose some other thing here, so I wrote more code. I want to and turns out I don't need it. Okay, so I select them. I want to comment again. Now in the Wolfram language comment syntax, you can nest them. So unlike C or C++, for example, the Java. Okay, where's my asterisk? I'm using the Glove 80 keyboard. If you don't know already, last week I did a video review. I'm gonna show you in a bit. Okay, so for example, here is a Java comment. Yeah, you see, Java and C comment, they cannot be nested. Okay, that is that is no good. That's a C style. That's why I despise C, C++, Java, those kind of languages, and Unix. They are like brainless. Okay, they are geared, they are designed, C, C++, those languages, and Java. C is a virus, then it beget C++, Java, JavaScript, C#. All those are shit. But over the past 20 or 30 years, they improved. For example, Java, about 10 years ago, they started to have Lambda. But anyway, the damage is already huge. C. Okay, so anyway, C. Okay, so for example, you have this comment. This comment, I believe, was it from C or C++? I forgot. Hello, Wang Yuan. What would you do if money grows? That depends. So one of the comment is that, and the other one is // okay. Actually, why don't we, since we are talking about it, let's just go elaborate. Let's go. Let's look up Wikipedia, because they have a. Actually, let's not go to Wikipedia. Why don't we just go to xar.d.info, because I have all these languages. Okay. So Java file. This is my Java tutorial. This is my Java logo. I designed it to reflect the complexity of the Java language. I did this, 2008. So the Java comment, okay, and my tutorial is pretty old, my Java language tutorial. So you can see there is a common syntax. Actually, I should make a new page that just describe how do you do comment in Java. So anyway, so here is the Java common syntax. So you have line syntax starting // or you have the /*. Now one of them is originally from C, the other one is added by C++. Now I forgot which one is which. Let's just for the sake, let's find out. Okay, so programming languages wiki, Wikipedia has a whole list of it. So comparison of programming language syntax. Okay, the reader wiki, list of programming languages. Okay, there is a page that list them. Okay, let's take some time. Let's just look. There it is, common computer programming. Okay, so this page, wait, where is my key to magnify? Yeah, anyway, so common computer languages. Okay, so you can see, let's see. Okay, I'm starting to get boring here. I need to move on. Syntax extension directive uses, normative views, needs for common, level of detail, block common. Okay, this is a common body variation 1, and this is the most idiotic ASCII art style common. That is, you use your text to create, to draw. This is okay, yeah, so this is from C, yeah. So the slash asterisk is from the C programming language, and it cannot be nested. Okay, so anyway, back to common. So but in Wolfram language it can be nested. Okay, now there is a problem. Now remember, I'm using the default, using the Emacs new common.el library to implement this. There's a problem. So if I select them and I want to comment out again the whole, if I do it, okay, it's, it kind of did it, kind of not. There are several issues. One is that it does the comment for each line. You see, instead of just adding bracket to the whole, it did it to each line. That's not so good. Okay, the other problem is that, you see, it added a backslash here, so that is a problem. That is wrong. I mean, yeah, that is wrong, incorrect, because once, if you add a backslash, that screws up the nested comment inside. So now when you uncomment, oh, actually it does work. Wait, how does it? Let's see. Interesting. But this shouldn't happen. This, you shouldn't have a backslash there. Okay, but it's not a major issue. I suppose I can live with it. Yeah. Now, if I live with it, then we don't need to write our own comment anymore. Standalone comment from scratch. Yeah. So there are two ways to go now. Now, if we want to fix this, undo, you see it added an extra backslash there. If we want to fix that, there are two ways to go. One is to dive deeper into the new common.el to see if there's some kind of configuration so that it doesn't add this extraneous backslash. That's one way to go. The other way is just write our own. Write our own is kind of, in some sense, much simpler, because your code, all you have to do is just write a function, basically. You write a function, and what the function will do is just, it will check if your cursor is currently in some kind of comment. So how do you check that? All you have to do is search backward for the comment beginning, search, and search forward to make sure it's not bracketed by comment. This sounds easier than it sounds. Actually, it's a bit more complex when you code it. So first of all, determine your cursor is inside the comment. If it's not, all you have to do is just add the beginning characters and end characters, either to the region, a block of text, or to a line. Okay, that's to comment. And if your cursor is already inside a comment, then you just find the beginning and end comment marks and remove them. Okay, so that is about writing your own command from scratch. Now, this is actually a very good Emacs Lisp exercise. I enjoyed writing it 14 years ago because it's purely text processing. Okay, and you can learn a lot Emacs Lisp using Emacs Lisp text processing powers and functions to write them. Okay, and I have a tutorial there. So write your own is one solution. The other solution is to look at the newcommon.el. Okay. So the newcommon.el, all we have to do is describe key, press the key for the comment, and hold on a second. Let me show the. Now where is my backtick character? Yeah. Okay, there. Okay, so you jump to my personal comment command. Wait, where is this Emacs Lisp? Okay, not this one actually. So actually you look for newcommon.el. Okay, let me do that. Okay, so jump to Softlight Keys. Now I actually have a wrapper that calls the command from that package. So common dream is the command from the package newcommon.el. Okay, common-dwim, meaning do what I mean. That's silly hacker type of naming. So common dream is the built-in command in Emacs that does common and uncommon. In my case, I wrote a wrapper so that I can just toggle, because the common dream default behavior, it doesn't toggle. It requires small keystrokes. Okay. So anyway, so common dream, so now you describe function common dream to look up its documentation, and then you just tab enter to jump to the source code. Okay. So we can see here's the documentation common dream. So what are we doing now is to look at this package. Yeah, okay. Let's just look at this package. Let's see, is there anything interesting? Is there something configuration we can do? Oh, look, there's a fix me. Okay, so yeah. Okay, let's do that then. So today I was planning to code Emacs Lisp, but I think we're gonna end up just talking about it, talking about it. Okay, so any comments and questions posted, okay, for people watching. Now, the keyboard I'm using, okay, so let me show you the keyboard I'm using. I want to promote it because I think it's a great keyboard and they gave it to me. So I did a video review last week. So this keyboard I'm using is called Glove 80. So you can go to my website and read all the reviews, okay? And there is a video I did last week, so you can watch it full. That's 1 hour review. It's pretty long and in-depth 1 hour review. Okay, check it out. Glove 80 keyboard. Okay, so reopen last closed, copy the URL back to Emacs, close this page. Now go to Talk Show. Today's talk show here. There is already a link here. Okay, so now show this in browser. So what to do next? Okay, we were planning to write a command, common uncommon command, but turns out the way it is kind of okay. So saw Emacs blog, close it, switch to yeah, minor problem, but it's okay. So let's see the comment. Let's just look at the source code then. Any questions and comment, ask me. Okay, so the whole thing is 1,500 lines. Who wrote it? Stefan Marnier, Emacs Lisp master. I respect highly. He is also a professor of functional programming research in Canada, I believe Montreal University. And he has been the leader, the main leader of GNU Emacs development for about 7 years, 2008 to 2016, something like that, okay? Stefan Marnier. Okay, so he wrote this actually when? Wow, 1999, wait. No, he's a maintainer. Okay. So let's see. So there's a question, usually I look at Lisp code. So right now my issue is, do I want to fix this? Maybe not. You should, of course, but you got a lot of things to do. I got a lot of things to do. I got Wolfram language, a lot coding. Let me talk random a bit then. Okay. For example, let me tell you about fantastic Wolfram language I did. Okay. So and math. Okay. So for example. Yesterday, in the past few days, we did this fantastic Wolfram language graphics. This is geometric inversion, okay? You talk to the C++ people, Unix people, they don't understand. They have no idea. They wouldn't appreciate it. But this, we did this, and it's just 5 lines of code, basically. You can actually 2 lines, 3, maybe you can make it 1 line. So you can generate, it's extremely beautiful. That's geometric inversion. Okay, so we did several videos of it. This one is from last year, Wolfram language, and then we did this one about a few days ago. Beautiful. It's this. I would say geometric inversion. The function is actually, if I have to say one, pick one. That's my favorite mathematical function. Of all math functions of my 20, 30 years of studying math, I would say geometric inversion is my favorite mathematical function. The idea, the concept is just beautiful and creates beautiful things. Okay, so I did this video. You guys go check it out. Wolfram language is a term rewriting system, so it's nothing like you never experienced before, okay? And 10 times, 100 times more high level than Haskell, Lisp, Common Lisp, Skin Lisp, whatever, okay? 100 times, no kidding. Not even counting the ability to solve differential equations or linear algebra or matrix equations. Those are mathematical functions. 1 line, you can, if you are going to implement those, doing derivatives, integrals, or solve differential equations, that's literally 10,000, 100,000 lines for each one of those functions, okay? And by default, Wolfram language has 7,000 functions built in. Okay, so those are mathematical functions. Each one is like, 100,000 lines of a common Lisp, a million lines of C++, let's say, each one of them. But let's not count those. Let's not count those that do mathematical functions. Let's just count for example, the functions that manipulate the list, delete, rest, take a slice of list, things like that. In that case, Wolfram language, each 1 line of Wolfram language is equivalent to, let's say, 10 lines or 100 lines of Python. Okay, it's incredible. So that's why I'm saying. So anyway, so I was saying, you can check them out. And yesterday I was, and Wolfram, the guy, which is one of the guy, one of the 5 or 10 top 5 scientists I have the most respect and whose point of view of the world on artificial intelligence, on the universe, on how physics, how mathematics is, I mostly agree on. I share a lot of the way he look at things. I truly do. And his style, his design of Wolfram language, the naming of functions, each programming language may be Larry Wall's Perl, Guido van Rossum, idiots, his Python, or the Java. Java is very formal. I mean Java, the naming, the kind of style, how you name your functions in a programming language reflect kind of the author, the creator of the language, their view of how, things. Okay, so Wolfram language, if you look at Wolfram languages, this is fantastic. Okay, let me show you. If you look at Wolfram language, you have, the naming of the functions, the style, how they name things. I very like it. I like it very much. That's the way I look at things. Okay, naming of things. I can give you some examples, but that will be another topic. Okay, and this relates to jargons, the use of jargons in programming community and in programming languages and in the programming field in general. There's a lot to talk about it. Scientific jargons. The other day I was debating with with a bunch of my people on Discord. Many of my friends, people on Discord. I'm debating, arguing about the megabytes, gigabyte, versus mebibyte. Mebibyte, kibibytes. Very interesting. So that's related scientific jargon. There's a lot to talk about that. How you name things, how when should the jargon be named and how should it be named, things like that. So anyway, we are going all over. Oh God. So today's so let's go back to Lisp a little bit, I guess. Oh well, okay, yeah. What I want to say is that there is Wolfram. Stefan Wolfram wrote these 3 parts, fantastic, blog. Each one of his blog is like 100 pages. So for me to typically to read one of his blog, it will take several hours, and that's just first skimming, several hours. So this one covers, the title is How Did We Get Here? The Tangled History of the Second Law of Thermodynamics. Okay, I don't know physics. I don't know physics too much at all. So, but I have read, I have read lots of other. He's on math, on logic, on artificial intelligence. Those things I know a lot more. Okay, but anyway, physics. So I'm, typically I'm very just amazed by the quantity. I mean, the style and the depth of his scholarship, okay, and also his style. His style is somewhat like, it's somewhat like the way I prefer, where you address to the people directly and communicate in the most simple words possible what you are trying to say, not the typical traditional scientific jargons which you usually stick with a traditional style, otherwise your thesis won't pass, won't get out, then it's bottled up or fucked shit. Okay, so anyway I digress. So I recommend this article. Okay, so for example, in this article there are 3 parts, and it turns out a few hundred pages altogether, like 1,000 pages or something, and there's deep scholarship. For example, all these signatures, these are by the people, the scientists who are, known, who are in the study of heat, thermodynamics. Okay, so that's their signature. You have to get, this is just on this page, just on this page alone. That's not trivial things to do. Okay, you got get those people are dead. Those are 1800s, 1900s scientists. These people, S. Carnot, William. This is Kevin. I think the Kevin known for the Kevin temperature. These people. And Maxwell. These people are well-known scientists. You have to get their signature and a lot historical documents. So in this page, in this part of the article, he's trying to tell you, essentially, he's giving you an overview of the history of the second law of thermodynamics. Okay, so I don't know physics myself, but from reading this, I learned that heat. Thermodynamics is basically the study of heat. Okay, so what is heat? What is heat? It turns out it's very quite interesting. It's and there's a lot still unsolved questions. Okay, so anyway, he's giving you a history, kind of how did the second law of thermodynamics were developed, and all the historical documents, writings. It's very interesting because you can read them. You can see some of them are in English. Okay, so for example, this one is in Latin, I guess. But some of them are in English, so you can see how people write back then. Of course, if if you are a mathematician, if you are a PhD, if you study a lot math, you should have done this. I mean, you should have seen this yourself. I mean, anyway. So these are many of the relevant snippets are here. So yeah, I want to say I always enjoyed reading his stuff. Okay, so and I know him so well, because I read Stephen Wolfram. I met him in 1995 because I went to work for Wolfram Research. I was an intern, supposed to stay there for 2 months, but I ended up staying for half a year, and was going to stay, but and then long story. But then I left because I was planning. I was supposed to go to UC Berkeley, but I didn't go anyway. That's my life, always wandering about. So anyway, so I, and I have been reading Stephen Wolfram since about 1992. All the article I can find, so I'm that type of person. Stephen Wolfram, and another guy I have read tremendously is Steve Jobs, for example. All the articles I can find, Steve Jobs, I highly admire Steve Jobs. And another guy is Richard Stallman. I have read entirety, basically, of his writings. Of those you can find mostly online around the year 2000. That which means the entire GNU website, Free Software Foundation. Yeah, but Richard Stallman, today is not too good a person. I don't admire. I admire Stephen Wolfram very much still, and Steve Jobs I also admire, and I think both of them are great person, but not Richard Stallman. Richard Stallman, I don't admire him. I don't think he's good. I don't think he's doing good things to humanity now. So anyway, back to so I was saying. So I read a lot of writings of Stephen Wolfram. So I kind of know a lot about him. As far as his scientific work. Yeah. not personally, not his family or whatever, but as far as his public writings, I know a lot. His style, his thinking, his view about lots of things. So what was I going to say? So yeah, so he wrote this a trilogy, you might call a trilogy, a trilogy of the second law of thermodynamics. Okay, I'm still reading it. I haven't finished. I spent several hours. I'm still reading it. But okay, so you see, right now we are only we are not even halfway through this article. So lots of things. Okay. And here, look at this one. The Logic of Chance, an essay by who is this? John Venn. Is that the guy famous for the Venn diagram? Randomness and its scientific treatment. Okay, randomness is such a fascinating topic. Okay, Logic of Chance, an essay on the foundation and province of the theory of probability, with a special reference to its logical bearings and its application to moral and social science and to statistics. You can read this. So this is from 1888. 1888. So this is about 100 years ago. The way, the different era, they have a different view of the world. So the Logic of Chance. And here then you have this this, I suppose that's a random walk, a very interesting diagram. So what is he saying? James Clerk Maxwell, John Venn, yeah. So John Venn is the Venn diagram. Yeah, I'm pretty sure. John Venn, English mathematician and logician best known for the Venn diagrams, okay, which can be used to visualize what. Okay, so let's go back. Interesting. So so there is a, yeah, so about John Venn, random walk, very interesting. Okay, so I recommend, okay, for those of you out there, young people, or fantastic, spectacular, scholarship, digging out the history of the second law of thermodynamics. Okay. Now, okay, so this article is long. We are just halfway in it. So let's go to the top. Let me tell you some of his other. So this is part 3. Then you go to part 1. Part 1 is the part he is the most excited about. In fact, because I know his style so well, I kind of know the way how he thinks. Part 1, so 3 parts, okay? Part 2 and part 3 are actually prelude to part 1. Part 1, the title is Computational Foundations for the Second Law of Thermodynamics. That's the real thing he wanted to say. So basically, again, this is like 50 pages, 50, look at this diagram. He's this is done by Wolfram language, of course. Fantastic facilities for graphical programming, visualization. So anyway, this is the main thing he wanted to say. He want to, he's, in the past, Stephen Wolfram's life's obsession is about cellular automata. And basically, in his view, you can use cellular automata to model the universe. And not just model. In fact, he believes that the universe, or the fundamental theory of physics, is actually the universe is just a computation. So starting with his publication, the new the new kind of science, which I have read several times. Hello guys, what are some good ways to grow money? Low cap. Okay, so I've been rambling all over, and I think we shut down in 5 or 10 minutes. Okay. Okay, so yeah, we begin to write Emacs Lisp, but oh yeah, so I want to show you a new kind of science. So just go to xali.info. You can search it there. Yeah, okay, let's just search it there. New science. So you can see notes on the new kind of science. So this book is, I think it's 1,000 or 2,000 pages. This thick. I forgot. Heavy. I have it somewhere. Put away. I read it more than once. 2 or 3 times, cover to cover. Okay. So I have so beginning with this work. So Stephen Wolfram is obsessed with cellular automata. And not just cellular automata, but he is interested in computation, basically automata. Okay, basically simple computation that you just compute, and cellular automata is a specific kind of it, where you kind of draw things on a cell, and and they evolve. You can see them evolve according to very simple rules. The rules are just like a program. So he's into computation, and his view is that beginning with this, this was published in 2002, around there, but in the previous 10 or so years, he been studying this a lot. He also created the entire field of complexity theory. Okay, he created a journal of it, and so on. Then this book came out. Then he still studied this, and then in the past few years he started to create a physics projects that basically tries to try to model the universe, answering all the questions in traditional physics by basing it on simple programs. Okay, that's essentially what he's doing. And that research, starting like 5 years ago, that turns out to then it turns out he also started to have it branched out into a structure of meta-mathematics that is a foundation for mathematics. For example, we have proof theory, we have proof systems, we have model theory, proof theory, we have or category theory, or sequence calculus and logic and homotopy type, theory. All these are kind of proof theories, but it's like they all have some problems, which each one is not perfect. If you add this, then it's more powerful, then something is missing, things like that. So he also created a kind of meta framework that somewhat gives you a insight about why you have all these different proof systems. So it's kind of meta. So it's and so that's one branch of it, meta mathematics, and what he would call rulers. Okay, I'm not gonna explain. Then another branched out is he wanted to find the fundamental theory, the grand theory of everything. Basically that's dramatic. That's a dramatic question. But basically, he wanted to create physics entirely with by the foundation, using the foundation of simple programs. The way the particular one he want to base on is multi-graph. Okay, it's called hypergraph. Okay, hypergraph. It's like a graph. Okay. So anyway, I'm rambling a lot. I don't think I'm going. So I lost. How many people are watching for? Okay, I think I'm just gonna shut down. What else you guys have to say? Any questions, comments? So I was going to say that he wrote this article, on the second law of thermodynamics, but if you just look at the graphics, just suppose you ignore everything else he says, because he's creating a grand theory, kind of, and to some traditional physicists, they may think this is not so valid. They may think that this is not too useful to the traditional physicists or mathematicians. So even if you ignore whatever he's trying to say, simply look at the graphics. Now this graphics is the most best done visualization ever. Okay, look at those graphics. Okay, not easy. And also, if you ignore all the physics things or thermodynamics things he's saying, you just look at this, whatever he's saying, purely with respect to cellular automata or simple computation. So it's very interesting, how would things, you begin with this pattern given with these rules. For example, here's a visual clue of how they evolve. So you start with a pattern, then you have these rules. How would it become? What would it become? So that's how you have all these graphics. Okay. And so if you look at his article purely from this point of view, computations, simple computation, cellular automata, okay, it's just amazing. Okay, it's non-trivial work. If you are a scientist, you can just publish this by itself without dragging into without trying to say you are actually modeling thermodynamics or physics. Okay, so I think it's very interesting and fruitful in research. Now I don't know whether he's the universe, his theory is going to be the actually critical for the future. He's saying that we have a multi-computational paradigm now, and today he says that we are entering into an era of multi-computational paradigm. Okay, and he's saying that his theory, he's I don't know how big this is, his physics project, but I don't know about that, but I know for certainty this is a non-trivial research, just purely from the cellular automata and computer graphics and programming language point of view. Okay, you look at those Python, JavaScript, D3JS, all those fancy things. This is 10 times better. So very interesting. And here I read a part of this article. Here he's talking about reversibility, equilibrium, and very interesting about how you can or you cannot create a rule that reverses, things like that. Okay. Yeah. So so this is a huge article. Okay, it takes many days to read them. I only and look at these graphics. Okay, this is how long does it take to do this? Okay, if you don't have Mathematica, if you don't have Wolfram language, this take you days to design, redesign, redraw this kind of thing. But with Wolfram language, it's much easier. But still, I mean, even still, it's not that trivial. Okay. Yeah. So amazing. I find it just amazing. Okay. Yeah. So Oh, and here is a compression. Okay. For example, he started with a simple compression scheme where he explained here. Okay, some then he tries to compress the image on the left, compress each line, and on the right is the result. Okay, so you can see when there's more pattern on the top, the compression result is very small. You got a great compression, but when the pattern becomes kind of randomish, then you don't have much compression, especially when it's wholly random. So very interesting things, even if you are not a physicist. Okay, I think that's very interesting. So I'm just okay, so I'm just saying my random comments on his Stephen Wolfram's work. Okay, so anything else? How's life with a new keyboard? Yeah, well, look at my reviews of it last week. Okay. Okay, so today I think that's it for today. Thank you guys for watching. I started to do Emacs Lisp, and turns out we don't need to do it. Okay, so that's it for today. Yeah. Okay, so this comment.el, new comment.el, is written by Stefan Marnier, which is great. So actually, yeah, I will have to spend time to actually look over it. I never did. So to see that if we're gonna write a to see that if we're gonna if I should use it or not. Oh, look at here is Pascal. For example, in Pascal, these are possible. Okay, so here is bugs. Boxed comments in Perl are not properly uncommented because they are uncommented one line at a time. Nested comments in SGML mod are not properly quoted. Okay, problems. Uncommon region. Okay, common syntax. Common quote nested will not unquote properly. Okay. Bye, guys. Yeah, closing, shutting down in 2 minutes or so. Okay, so close that. So some common dream, close that. Okay, here's sample comment in Wolfram language. cut it, close it. Okay, now let's go to talk show and open this, and let's just put a Wolfram language code, paste it there, color it, show in browser. Okay. Thanks, bye. Bye.